Okay, and I'm gonna turn off my camera because I may need to write on the screen. So I'm gonna turn off my camera and I'm gonna share the handout that I have shared with you earlier. Okay, so what we are going to do, we are going to talk about, where's my handout? All right, can't see that, it's my PDF. All right, so where's my PDF? Let's see this, if I can share here. Look at this is, okay. So if you guys remember, I shared this handout with you earlier on the, I think in the first email. So this is more like a theoretical background that we are going to create now. I hope you guys remember what we talked about the periodic table in Brave, right? We talk about the horizontal rows, vertical column. We talk about different names for them. We figure out where we call it as a metal element, where do we call it as a non-metal, where do we call it as a metalloid, right? In case if you do not remember, we are briefly going to touch that basis now. All right, so what I'm going to do, I'm going to give you more like a theoretical background. And once we finish that, we are going to practice on how to name the compound. So there are actually two different type of compound that you guys should know. The first one is ionic compound. The second one is covalent compound. So we're gonna know if the formula, if the chemical formula has been given to you, how you can write the name, and vice versa. If I give you the name, how you can write the chemical formula. All right. Many students kind of may struggle in this case, but what we are trying to do, we are just trying to build up a knowledge, right? I'm going to give you plenty of time, plenty of practice example. So hopefully it will be easier for you. And that is the reason why I have shared another two handout with you to make it easier for you guys. Okay, so we are, first of all, we are briefly going to touch the basis on theoretical part, and then we're gonna practice on the naming and the writing a chemical formula. Everybody sounds good? Yeah.
Yes, Professor.
Yes. Yeah, awesome, awesome. So if you guys remember, we talked about in the last session that every box in the periodic table is called an element. I hope you guys remember the periodic table. Let me see if I can open it here. All right, just give me 1 minute. I'm gonna open the periodic table. All right, so this was the periodic table we talked about, right? So you can see like so many boxes in this table, right? And every box, every individual box in this table is referred as an element, right? So we're gonna go back to the other handout and we're gonna talk about it. What is an element? I'm not asking you to define it. I'm simply explaining you this to understand. Okay. So this is not a definition. This is something you can remember. So every box in the periodic table is referred as an element. So if you see the box, you know that is an element. For example,
I'm sorry, Professor, but we can't see the table on your screen.
Yeah, the screen is frozen.
It's frozen?
Yes, Professor. We cannot see anything. The screen is frozen.
Yeah, I can't see.
Can you see the element and compound screen?
No,
Nothing.
All we see is your files open screen.
Okay, so stop sharing. All right, I'm going to share it one more time. Did you guys see the periodic table before or you did not?
No.
Not at all. Okay.
Nope.
Not at all. Okay. All right. So just give me 1 minute. I'm gonna open it in another browser. All right. This is my periodic table. Okay, I'm gonna keep it separate. All right. I'm gonna keep them separate so you should be able to see them. And I can just close. All right, so let me go back, close, share. All right, can you guys see the periodic table now?
Yes.
Yes.
Yeah, awesome. So this is the same periodic table that we talked about in the last session. Again, just a reminder, every box, for example, this box you're seeing on the right side of the periodic table, every box is referred as an element. What information do we have in the in each of this box? The first one is there is a number, right? If you look at the number, right, every box has a number on top of this. So 1, then on the right side of that is 2, then in the next row is 3, then 4. The number that goes up sequentially 1, 2, 3, 4, 5, 6, 7, 8, 9 up to 118 is referred as an atomic number. All right, the number that you're seeing right now, that is referred as atomic. I'm just going to write the number like this. Okay, so it's atomic number. Then what you see here is a symbol for an element, right? He is a symbol for an element. What is the name of the element? The one that you're seeing right underneath that, helium. The name of an element is helium and the symbol is He. And there is another number which you see at the bottom of the box, which has the decimal place. All right, that's how you can remember this. Sometime if you look at the different periodic table, it may change the position, right? The number one, like the number that goes up sequentially are not always on the top. Sometimes it is on the right top, sometimes it is on left top corner, right? It depends. However, as long as it does not have a decimal place, you can identify them as a atomic number. And if something has a decimal place like 4.0026, right, that is called mass number. This is called mass number. Today we are going to define this in a detail. Okay, last time we did not, today we are. So this is the periodic table and this is every box in the periodic table. Again, if somebody has missed it, I'm just going to repeat this information. So every rows that you see here, 1, 2, 3, 4, 5, 6, and 7, right? That is in the scientific language or in the chemistry language, we are going to refer that as a period. Remember that every time when you see word period, that is what it means. It means horizontal rows. If you look at the vertical column like 1, 2, 3, 4, right, 11 and up to 18, that's what we generally refer as a column. However, when we refer to the periodic table, we call them as a, anybody remember that?
Group.
Excellent, right? We call them as a group. Okay, so vertical column is called as a group, horizontal row called as a period. Everybody sounds good? Yeah?
Yes.
Yeah, okay. So I'm going to stop.
Yes.
Yes, thank you guys. I'm going to stop sharing this and I'm going to share my another screen once again, just to make sure that you guys can see it. Everybody can see element and compound handout? Yeah?
Yep. Yeah.
Yes.
Yes.
Awesome, great. So that's what we just talked about, right? What is an element? Every box that we just saw in the periodic table is referred as an element. Now, what we are going to talk about it. Now we're going to go in a microscopic level. It means we are going to go in a detail. So let's say if you have this element, let's say this is your element, right? For example, iron. Let's say this is iron, right? It's like a ball of iron, let's say, right? The tiniest particle of this element, which has all the same properties, what do we call that? We call that as an atom. So what we can call a building block or the smallest unit that shows all the property or that has all the characteristic of an element is called an atom. So tiniest particle of an element is referred as an atom. An atom is something we cannot see with our naked eyes. Okay, so we can visually see atom. All right, so the building block, smallest unit or smallest particle of an element is called an atom. The next definition, right, is compound. What are the compound? So when two or more element comes together, then they form a compound. It's simple. Initially, what we say, every box in a periodic table is called an element. However, if you have more than two elements, two or more basically, right? If you have two or more element comes together, join together, form a bond or form some sort of connection, then it is forming a compound. And what is the building block of a compound? Just like the element, the building block is atom. For a compound, the tiniest particle of a compound that has same characteristic, right, then it is called a molecule. So these are the terms that you should be able to understand. What is atom? Atom is a refer to the smallest particle of an element. What do we call as a molecule? Molecule is the smallest particle of a compound. Again, atom and the molecule is something we cannot visually see. All right, it's very, very small and tiny. Does this make sense, everybody?
Yes.
Yes.
Right, so this was the theoretical part. We are still going to talk about more theoretical part, and there are two laws that we are generally going to refer to. These laws are really simple. All I'm going to do, I'm just going to read this once and then I'm going to explain this to you. The first law says law of a conservation of mass. Conservation means retaining, the mass means the weight. Okay, so what it says, the atoms are neither created nor destroyed. It means the atoms that we talked about, you cannot just destroy them. What is that going to happen? They are only changing into another type of atom. So instead of this atom, let's say if it's iron atom, Fe, by itself, if some sort of reaction happen, what is going to happen? It is only going to convert it into another type of atom where it is connected to something else. You cannot just destroy them. You cannot just get it out of it. Okay. And what it says, the total mass of a matter before and after the chemical reaction is the same. Very simple example. What I would say, let's say if Na is reacting with AgNO3, you don't have to understand like these formulas. All I'm trying to do is I'm just trying to put two simple chemical together. All right. And if you're going to form NaNO3, right, I'm just going to say plus NAG plus. All right. So let's say some sort of reaction is happening, right? Let's call this as a compound. Let's just call it as a number one, reactant number one. Let's call this reactant number two. All right. If you have 5 grams of Na plus and 10 grams of AgNO3, this is G means grams. So total weight or total mass that is going into the chemical reaction is equal to 15 gram. Everybody agree?
Yes.
Professor.
Yes.
Right?
Yes, Professor.
Great. So let's say if we are going to produce, for example, 9 gram of NaNO3, then the quantity of the AgNO3 will be remaining gram. It means it's going to be the 6 gram. What it says, it simply says the gram of the reactant, right, that goes into the reaction will be equal to the gram of the reactor product that is coming out of the reaction. So what it says, the total mass before and after a chemical reaction is the same. All right. Do you guys follow this?
Yes.
Yes. Yes.
All right. This is just for your understanding. In general, nobody is going to ask you this kind of question, but you should be able to understand what is conservation of mass. Conservation means retaining or keeping it. Mass means you are keeping the same mass. Let's say if you putting 100 grams of let's say sand into one container, right? You're putting in a like a some sort of heating machine. At the end of the reaction or end of the machine, let's just assume that you are getting out of stones, right? The mass of the stone that is coming out of the machine will be same as the mass of the sand that you put into the machine. That's all it says. Okay, do you guys follow this?
Yes.
Yes, but I
Yes,
do have a
Professor.
question.
Yes, go ahead, question.
Is the mass of an element or a compound is the same as the mass, the answer, or is it only for the elements or
No,
only for the compound or both?
Yeah, it is talking about the total mass. So in here, the total mass is 15, right? So whatever is going to come out together would be 15. All right, so we are not looking at the individual mass of an element or a compound. All right, we are looking at the total mass that goes into the reaction. So if it's total mass of, let's say we have 10 different compounds, right? And 5 different elements. The total mass of that mixture is, let's say, 50 grams. Then, and in the end of the reaction, we are getting 7 different elements and let's say 8 different compound out of the reaction. The total mass of them would be 50 gram as well. So no matter if it's just an element or a compound, we are just adding those mass. So the quantity that goes into the reaction, the grams, will be the same quantity that is going to come out of the reaction. That is going to be irrespective of the element and the compound. Make sense?
But what I'm trying to say, let's say, for example, we take one compound, and then we put heat on it, and then we transfer it. Is it the same as let's say it's a water, for example. Water is a compound, right?
Yes.
And we make a heat, we heat it up. Is it gonna have the same mass after or not? That's my question.
Yes. Yes, it's going to be the same mass.
Okay, so it doesn't matter if it's compound or elements.
Yeah, it doesn't matter in that case.
Thank you.
Yeah, in general, what we talk about is reaction, right? What is a chemical reaction? It is basically when 2 compounds mix together, it forms something new, right? And because it's forming something new, I gave you this example that it is not the same as what we started with, right? In the chemical reaction, what happened when you mix 2 compound, or when you mix 1 element and 1 compound, or when you mix 2 elements together, at the end of the reaction, something new comes out. And that is why we call it as a chemical reaction. If nothing happens, then it is not a reaction. Yeah. So that is why I gave you this example. But for simplification purpose, you can give that example. You can consider that example of a water. And yes, that is right. Okay.
Thank you.
No problem. All right. And the second law says constant composition. It means a given compound will always have same type of atom, always in the same number. Just the way that you gave me the example of water. What is the chemical formula of water? Do you guys know that?
H2O.
Excellent, right? If you guys know that, it's awesome. If you don't know, now you know. H2O. This is the chemical formula, or this is the chemical way we can represent a water. H2, it means 2 atoms of the hydrogen, and O. O means just 1 atom of oxygen. So this is the chemical formula of a compound. What it says is a constant composition, means if I give you 1 drop of water, then the chemical formula is H2O. And if I talk about the entire glass full of water, it is still H2O. And even if you talk about the water in the sea, right, it is still represented as H2O. What it says, it means if you want to make a compound, that whatever number of elements that are coming together, they are always going to come together in the same proportion. It means there is always going to be 2 hydrogen, and if there is no number here, it means 1 oxygen. So when there are 2 hydrogen and 1 oxygen comes together, they form a compound, which is water. So even if you talk about 1 drop, 50 gram, 100 gram, 1000 gram, gallons, the chemical formula remains same. It means the chemical composition remains same. You get it?
Yes.
Everyone?
Yes.
Yeah. Awesome. All right, let me see if I can scroll this down, and if you can see. Can you guys see the
Yeah.
atomic structure now?
Yes, Professor.
Yeah, awesome. Now what we're going to talk about, we are going to go further deep into the atom, right? We just talk about it, that the smallest particle of an element is called an atom, which we can see. Now we are going further deep into the atoms. The reason why we're going in this direction is initially, like we don't have the technology that we can go deep into it. Now we have more technology, so we can, we can even go further into detail and say, okay, the atom is not the smallest particle. We even have, even atom has something in it. So what we call atom structure, it means what atom is composed of. And you may have heard about this. Generally, atom is composed of three particles. What are the name of those particles? Proton, neutron, and electron. Have you guys know this?
Yes.
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 Right. So just keep in mind, what is atom composed of? Composed of three particles. That is called proton, neutron, and electron. Now, generally, when we talk about this proton, neutron, and electron, we generally refer to the charges of this particle. So it is very simple to remember. Proton generally carries plus one charge, pp, right? Proton, positive charge. Electron, negative one charge. And the neutron, it sounds like a neutral, it does not carry any charge. It means you can call it as a charge 0. All right, can you guys understand this? Can you guys follow this? Remember this? Proton, always plus 1. Electron, always minus 1 charge. And neutron always carry no charge, or you can say charge 0. Make sense?
Yes.
Yeah.
Yes, of course.
Awesome, awesome. Now, what we're going to talk about is how does the atom structure look like? So generally, atom has a nucleus and there is a surrounding area. All right, so this is how generally we can assume that atom should look like. This we are going to call it as a nucleus. It means the center, right, of an atom, and this is the surrounding area. Right, this is our surrounding area. What do we have in the nucleus? Which particle do we have in the nucleus? Within the nucleus, we have two particles, proton and
Neuron,
neutron.
neutron.
Yeah. So remember this. What particle do we have in the nucleus of an atom? Within the nucleus of an atom, we have proton and the neutron. Again, proton carries positive 1 charge, neutron are neutral. It means do not carry any charge. And what do we have outside of this nucleus? So this is our nucleus. Once again, I'm just going to highlight it even more so you can focus. And outside of this nucleus, it means that in the surrounding area, what do we have? We have electron. Electron are in the surrounding area. Surrounding of nucleus. And what charge they are carrying? Again, they are carrying negative 1 charge. All right. So how can we say that electron are always in that limited area? The reason is there is always attraction between positive charge and the negative charge, right? If you look at the central, right, or the nucleus of the atom, the kind of charge we have is a positive charge, right? In the nucleus, we have proton, which carries positive charge. Around the nucleus, we have electron, which carries the negative charge. So there is a there is an attraction between the positive charge and the negative charge. So that's how this electron are going to stay in a limited area around the nucleus. Okay. And because they have two different charge, right? When we talk about an element, we can say overall element like hydrogen or helium, right? Whatever element we are want to talk about, all these elements are neutral. Neutral means they do not carry any charge. What is the reason? The reason is because the charge of the proton that they have in the nucleus will be cancel out the charge of the electron that they have in a surrounding area. It means the positive charge and the negative charge will cancel out each other. And that's the reason why the element overall do not carry any charge. But within the atom, we can say we have positive charge in the nucleus and the negative charge surrounding the nucleus. But both of these charge eventually cancels out each other, and that's the reason why all the element in the periodic table are always a neutral, do not carry any charge. Do you guys follow this? Yeah.
Yes.
Everyone?
Yes.
Yeah. And any question? No. Okay. So now we can, because we talk about the proton, neutron, and electron, now we can explain what is atomic number means. You remember we talk about it. Every number in the periodic table that goes up sequentially 1, 2, 3, 4, 5 up to 118, we call them as an atomic number. Now, if we want to define or explain what atomic number means or what information we can get it from that, is atomic number represent the total number of proton. All right, atomic number is equal to total number of proton. So for example, the first element, which is hydrogen, the atomic number for hydrogen is 1. What does it say? It says it will have 1 proton. Do you guys follow this?
Yes.
Yes.
Yeah. So let me give you an exercise. Let's see if I talk about carbon. The symbol is C. What is the atomic number for carbon? Can you guys look at the periodic table?
6.
And what is
6.
the number?
6.
6.
6. Everyone agree? Right? It is the 6th box in the periodic table. It means it has atomic number is 6. Now we know it is atomic number, but now what we just learned, we talk about atomic number is equal to number of proton. It means we can say carbon will have 6 proton, right? So just by looking at the periodic table, looking at the atomic number, you can say how many proton carbon or any other element across the periodic table can have. All right, let's talk about the second definition. What is the mass number then? The mass
12.
number.
Oops, sorry.
Great. No, that's okay. That's right. Right. Let's just define it. Right. And then we talk about the number. What is the mass number? What is the explanation? What information we can get by knowing the mass number? The mass number is equal to number of proton plus number of neutron. It means it just adds up whatever we have within the nucleus, right? Because in the nucleus, we have proton and the neutron. So the mass number is equal to number of proton plus number of neutron. So again, as you just answer, if I'm going to ask you the same question, what is the mass number for carbon?
12.
12.011.
Right, 12.011. So let's just say 12.01 at the moment, right? That is the mass number. If I say this is the mass number, what does it mean? It means it is the total of the proton and the neutron. So proton plus neutron. All right. So what is the use of this atomic number and the mass number? Of course, to find out how many protons we have, how many protons and the neutrons we have. And you are definitely going to see such kind of question in your exam 1 as well as in the final exam, that if I give you a symbol and I'm going to ask you what is the number of proton, what is the number of neutron that we have. Let's just take an exercise with the simple one. I'm going to explain this to you and then I'm going to give you an exercise. Okay. So let's talk about fluorine. The symbol is F. Okay. If I'm going to ask you what is the atomic number for fluorine, that is going to be what?
9.
Everyone?
9.
9.
9, right? Atomic number for fluorine is 9. If I'm going to ask you what is the mass number for fluorine, what you will say?
998.
18.998 or 17?
18.998. That's what
Okay.
fluorine says in the table
Okay.
you gave us.
All right, so 18.998. All right, what does it mean? We can just round it off. I'm going to explain this to you when we're going to round it off and when we are not. We are going to round it off to 19. Okay, because it's 18.99, right? So it's almost 19. By knowing this number, let's say in the exam, if I or your lecture professor ask you, find out the number of proton. What should be your answer then?
9.
Very simple, right? By knowing the atomic number, what we just learned, we learned that atomic number is equal to number of proton. So if atomic number is 9, we can say the number of proton is equal to 9 as well. All right. So remember that. The next question could be this. What is the number of neutron?
10.
10.
Right? If I ever ask you or your lecture professor ask you what is the number of neutron, what you're going to do, you're just going to use the formula for the mass number. You already know the mass number, which is 19 here. By knowing the atomic number, you know there is a number of proton, which is going to be 9. So how many neutrons you will have? So of course, you're going to have 19
10.
minus 9 would be
10.
10. So you will have 10 neutron in the fluorine. Easy? Make sense?
Yes.
Yes.
Everyone? Yeah.
Yes.
Now we already, great. Thank you guys. Now we already know the number of proton and number of neutron. What about number of electron then? It is very simple for an
9.
element.
Mine
Excellent.
9 is 9.
Okay, so when we talk about the charge, it is different. It could, when we talk about charge, we can say positive and a negative. When we talk about the number, we just call it as a number 1, 2, 3, 4, 5, 6. Okay, so it's not negative 9, it will be plus 9. However, I'm going to explain this to you. What did I just say? For every element, the positive charge and the negative charge cancels out each other, right? It means both number will be the same. The number of proton is going to be the same as number of electron. So that is the only how which we can cancel out the positive charge and the negative charge so that element can be the neutral in charge, right? Or carry no charge. So by knowing the atomic number, you can say if the number of proton is equal to 9, then the number of electron is going to be 9 as well. Do you guys follow this? So
Yes.
whatever is number of protons we have, the number of electron will be the same. This is true when we talk about an element. Why? Because element do not carry any charge. The number of proton and the number of electron will be same. Everybody good?
Yes, Professor.
Yeah. All right. So let me give you an exercise in which I want you to answer all of this, right? I want you to find out the atomic number, the mass number, number of proton, number of neutron, and number of electrons. Okay. So I'm going to give you an example. Let's say, let me give you something interesting. All right. I do want you to look at, like, refer to the periodic table. So I'm going to give you something a little bit challenging, not that much. Potassium. All right. Let's find out where is the potassium in the periodic table. I'm going to give you like 2 minutes. All right. Take your time. Find out where is the potassium in the periodic table. Look at the atomic number. Look at the mass number. do your calculation to find out number of proton, neutron, and electron. I'm gonna give you 2 minutes for that, okay? All right, guys. Anybody has any answer?
Yes.
Yeah. All right. So let me just write this. What is going to be atomic number?
19.
19.
19.
19. Great. What is going to be the mass number?
39.
0.098.
3909. All right. What is going to be the number of proton?
19.
Everyone?
19.
Yeah.
19.
Great, great, great. Because the atomic number is equal to number of proton. What is going to be the number of neutron then?
20.
20.
20.
20.
20. Excellent. And what is going to be the number of electron?
19.
19.
19. Great job, guys. Remember, this is definitely going to be the part of your first exam question. All right, you already got like at least 2 point or 4 point worth answers, right? So this is something that generally like like 2 to 4 point question. Okay, so you got this. So that's excellent. So keep in mind, it is really, really simple. Also, something to keep in mind is when we call it as a number of proton, number of neutron, and number of electron, it is always a whole number, right? So either it is 18 or it is 19. It is never 18.5. All right, same thing for the neutron, either is 20 or 21. It is never going to be 20.01. Sorry, 20.2 or whatever it is, right? It is always a whole number. This is not the case, right? It is going to be always a whole number. However, what I just explained this to you is what is mass number? Mass number is equal to number of proton plus number of neutron, which you generally see at the bottom of each box. Why does all those number, all the mass number has the decimal place in them then, right? When if we call the number of proton is a whole number and the number of neutron is a whole number, the total should be just 39. Why do we have like 39.09? Why do we have something like that?
Don't they actually include the weight of the electrons in the mass number?
No, it is because of different isotopes. So we are going to talk about what are the isotopes. Okay. So, all right. So let me just scroll this down a little bit. It is just a definition at the moment, right? And there is a formula underneath it. So what is isotopes? Isotopes are, they are having identical atomic number. As we know what is atomic number by now, right? Isotopes are having identical or same atomic number but different mass number. What does it mean? It means that it will have the same number of protons and you can also call same number of electrons. However, they are going to have different number of neutrons. So when we talk about, for example, carbon, let's just assume that we are going to, mine the carbon from one area, and let's just assume that we get 100. I'm not going to use any unit just to make it simple. Let's just say assume that we found out 100, let's say particle, right? 100 particle of the carbon, right? If we dig into some area, we found out 100 particle of carbon. All those carbon are going to have same atomic number? Yes. But there is a large chance in which they can have a different number of neutron. And if they have the same atomic number but different mass number, or we can say in other word, different number of neutron, they are referred as isotopes. So if we're going to present the isotope, we can say there is a carbon which can have atomic number which is 12. Sorry, mass number which could be 12. There is a carbon which can have the mass number as 13. And there is a carbon which can have the mass number of 14. Okay, so basically you don't need to remember how many different isotopes are there for each element. However, that information will be given to you in case if that kind of question your instructor is going to ask. What do you need to understand is isotopes are the one which has the same mass atomic number, but it can have different mass number. It means it can have different number of neutrons. So in this example, if you're assuming that we found out 100 particle of carbon, we can say the 96 of this particle are in this form, right? Which will have 12 mass number and 6 atomic number, while 3 of them could be in this form, in which they have 13 as a mass number and 6 as an atomic number, while one of it is exists in this form, in which it will have 14 as a mass number and 6 as an atomic number. So the total is 100, that's right. However, because they are having a different mass number, what we have to do, we have to average them down. Okay, we have to find out what is the average number. And that is the reason why these numbers have a decimal place, because when we do the average, this can have a decimal place. All right, so I'm going to show you the formula for that. But before we do that, let me just help you understand this. What did I just write here? So in the exam, right, or maybe in the book, you may see a presentation like this, in which you can have a number as a subscript, then there is a symbol of an element, and then there is a number on a superscript. So how do we read that? So the number in the subscript, the lower number, subscript means the number is which is on the lower side, right? That number is referred as atomic number. We already know what is atomic number. Atomic number means number of proton. It means if you ever see a presentation like this, which I just write here, the lower number represents the atomic number, which is number of proton. Then there is a symbol of an element, and the number on the top represent the mass number. Okay, what is the mass number? Again, the mass number is number of proton plus number of neutron. And what I just said, as isotope are the one which can have the same atomic number. So you can see in this 3 example, all the atomic number are same, 666, which we already know if you look at the periodic table for the carbon. However, it has a different mass number, 12, 13, and 14. So basically, carbon exists in 3 isotopic form. Okay, so when we average them down, we can do the calculation, of course, and that's how we can get a mass number which will have the decimal point in it. Okay, what is the formula? How we can find out the average atomic mass, or we can say the mass number of an element? The formula is very simple. What we're going to do, we are going to use the percentage, right? What did I just say? let's say if we find out 100 particle, out of 100 particle, 96 of them will be in this isotopic form, 3 of them will be in this isotopic form, and 1 of them is going to be in this isotopic form. So if we want to do the average, what we are going to do, we are going to write a formula in which we are going to say percentage abundance. Percentage abundance means the number that I gave you, right? The percentage, 96% will be in this form, the first form, isotope 1, right? So what I'm going to do, percentage abundance multiplied by the mass. In this case, what is going to be mass? Mass is going to be 12. This is going to be for isotope 1. And whatever number of isotope you have, you are always going to add them up and keep repeating the same step that you did. So plus for isotope 2, what you're going to do, percentage abundance multiplied by mass, you're going to put in the quantity for isotope 2. If you have 3 isotope, you're going to add 1 more, percentage abundance multiplied by mass for isotope 3. If you just have 2 isotope, you're just going to do 2 steps. If you have 3, you're going to do all 3. If you have 4 isotope, you're going to do it 4th one as well. For exam, remember this, the percentage abundance and the mass will always be given to you. All you need to do is remember this formula and multiply this. As long as you do that, your answer will be there. Okay. So what is percentage abundance? Abundance means how many percentage or how many molecules are existing in this particular form. For this example, we can say the percentage abundance is 96. What is the mass? In this case, the mass that we found out is 12. So this is 12. What is the percentage abundance for isotope 2? We can say it's 3%. So it's 3%, right? I have to use the percent sign, or I can say divide by 100. And what is the mass for that isotope? It is 13. You got it? And you can
Yeah.
just keep on going, right? 1% in this case multiplied by 14. When you simply do this math, you will get your answer. And when you get this answer, that will have the decimal place in it. And that is the reason why the mass number, even though it just represents number of proton and number of neutron, it has the decimal place in it. All right, do you get it?
Yes.
Everyone?
I understand it. Would we be able to solve the example that you said?
Of course, in later on, like when I have let me just, okay, so what I can do, I may need to find one. So we can definitely work on this. Okay, so let me give, all right, so just give me 1 minute. I need to find one question and I'm gonna share that with you. Okay. So meanwhile, what you can do is just try to look at this formula, right? You already have this in the handout. Try to understand the formula. Okay, so just give me 1 minute. I'm just going to look for the example question. And all right, so I'm going to stop sharing this. All right, I'm going to look for it in my computer. Stop. And screen. All right, so I'm going to share this my screen. Here. All right, so everybody can see the learning check PowerPoint slide. Yeah.
Yes.
Yes.
Right.
Yeah.
Okay. So in the exam, something like this can be asked, right? This is the question. It says gallium is an element found in a laser used in a compact displayer. In a sample of a gallium, there is, so this is still a question, right? Up to, so it says there is 60.10% of gallium exist in this form. It means the atomic, we can say the mass number, or we can also refer that as a atomic mass, is same meaning, right? Mass number or atomic mass, mass of an atom, right? It's the same. So 69 Ga atoms. So what we can say, 60.10% of a gallium will have the mass number of 69, while the 39.90% of a gallium will have the mass number of 71, right? What is the atomic mass of a gallium? Sometime it can be asked, what is the average atomic mass of a gallium, right? So what you are going to do, you are simply going to multiply this. So the formula that I just gave you was this. I'm just going to write the formula once. Percentage abundance. Abundance means the availability, right? Multiply by mass of an atom, or generally referred as atomic mass. Now, if in this example, as you can see, there are two isotopes, isotope 1 and isotope 2, it means you are going to repeat this step 2 times. If there are 3 isotopes, you can repeat this step 3 times. Okay, so for first step, for the first isotope, what we can do, we can say the atomic mass that we have is 68.926. So we're just going to use that number, multiply by percentage abundance, 60.10%. So remember, whenever we use the percentage, what we can say, divide by 100, right? That's what the percentage sign means. So if the number is given as 60.10%, you can write it as 60.10 over 100, right? Everybody understand that? Yeah.
Yes.
Right? So what you did, we just used the mass, the atomic mass, multiply by its percentage abundance, do the math. So we got this number, 41.42. Now what we're going to do, because there is 2 isotopes, we are going to do the same math for the second isotope. Second isotope has the mass number or atomic mass 70.925, multiply by the percentage abundance, which is 39.90 over 100. If we do the math, we got this number, 28.30. All right. Now we have the number for each of the isotope. What we are going to do, we are going to add them up. So this is the number that we get from the first isotope. This is the number we get from the second isotope. So if we add them up, it is going to be 69.72. So that is the reason why the gallium, right? You can look at the gallium in your power periodic table. The atomic number is 31. The mass number is going to be 69.72. The reason is it is having 2 different isotopes which are present in a different percentage. Okay. Do you guys understand this?
We always get the percent, right?
Yeah, both of this number, right? The percentage abundance and the atomic mass for all the isotope will always be given to you.
Okay, great.
Right? So all you have to do is just use the formula that I just show you and plug in the numbers. All right, let me just show you one more example so you can understand this, right? The formula is still same, right? It's just different presentation. This is the calculation for step isotope 1. This is the calculation for isotope 2. As a part of the question, what you will have the atomic mass, which is 39.90 sorry, 34.97. And you will also have the percentage abundance. In this case, it is 75.76%, right? This is example for chlorine. The atomic number is 17. The mass number or atomic mass is 35.45. How do you get that? So there is, again, there are two isotopes. The first isotope exists as 35. The second isotope exists as 37, right? What is the percentage of them? 75.76% of the first isotope, 24.24% of the second isotope. So both of this number, the mass and the percentage abundance of both isotope, or if there are three, then all three isotope will be given to you. All you have to do is multiply them, get the number, multiply them, get the number. And once you get that number, add that number and find out the average atomic mass. All right. Do you guys follow this?
Yes, Professor.
The average is always when we add the both the two formulas and then we divide them by 2. That will be the average, right?
Okay, not in this case. When I say average, it means you're just adding them up in this case, right?
Oh.
You're not dividing them. Average means like you're considering the weight, like the contribution from each isotope, and you are putting it together. It means you are just simply adding them. So 26.49 plus 8.962, the total is 35.45. So I'm sorry if I say average in that sense, but yeah, it's simply addition. Okay, my bad. You're simply going to add the answer that you get from each isotope. Just add them up. Okay.
Yeah.
Okay.
And here, just to give you an idea that different element, right? Lithium, carbon, oxygen, fluorine, sulfur, potassium, and copper, different element can have different number of isotope. For example, fluorine, it does not have any other isotope. It is just one isotope. And that is the reason why the atomic number is kind of very close to the whole number, right? Like 19, 18.99, right? Which is very close to 19. That is the reason, because it does not have any isotope. When you have more isotopes, right, there are more chances that the number looks like different. So if you have 3 isotopes, in this case, sulfur, right, 4 isotopes, potassium, 3 isotopes, you can see a number differ from the whole number. The reason is because there are more isotopes. We have to do the more calculation. We're going to add them all those numbers. There are more chances that we can have a number after decimal point. All right, so the potassium can have 3 isotopes. In this case, copper can have 2, oxygen can have 3, right? But you do not need to remember how many different isotopes this different element has. This information will be given to you as a part of the question. All you have to do is use the formula, find out the number for each isotope, and add them up. Sounds good?
Yep.
Yeah.
Yes.
Yeah. Any question before we move on? All right, so I'm going to stop sharing this. And let me see what I was discussing. All right, so all right, so now we are going to, okay, I didn't share that. So again, I'm going to share my screen once again. Here. All right, so we talk about the isotope and what formula we have to use. Now we are going to talk about the periodic table, which we already have done. So I'm not going to go repeat myself, right? So we talk about what do we call as a period, what do we call as a groups. I also talk about there are 4 names that you need to be familiar with in the last lecture. In the last session, we also talk about what are the metals, non-metals, and metalloids, right? Just to give you a basic kind of helping you to recall this. right? What are the metal? So most element which you see on the left side of the periodic table, they are referred as metal elements. Exception is hydrogen, right? Now, how do we define which is the left side and which is the right side? It depends on the metalloids. As long as you know where is the metalloids, right? It's like a zigzag fashion. That's a separation, right, across the periodic table, which we have already talked about. So that zigzag fashion element are called as a metalloid. Anything on the left side of that zigzag is called metal, and everything on the right side of this zigzag is called non-metal. Okay, so if when I say left side and the right side, I refer to this metalloid, right? The zigzag fashion portion of the periodic table that we talked about in the last session. Also remember that there is an exception. Even though hydrogen is on the left side of the periodic table, it is considered as non-metal. So please remember that. Okay. Now we are briefly going to talk about what is molecular formula, empirical formula, and structure formula, right? And then we are going to talk about the different compound that I was talking about. So as we know, H2O is a chemical formula, right, of a water. This is how we can represent a water molecule, right? So when we talk about this kind of formula, that if you want to be more specific about it, we can call it as a molecular formula. What is molecular formula means? Molecular formula shows total number of atom of an each element present in a molecule. It means, for example, water, we just talk about it. Every water molecule is composed of two atoms of hydrogen and one atom of oxygen. So when you put them together, H2O, this is referred as a chemical formula. But if you want to be more specific, you can call it as a molecular formula. Okay, so H2O is a molecular formula for water. Similar way, if I want to write the formula like this, C6H12O6. Okay, what is this? This is sugar that we generally eat, the table sugar that we eat. Okay, C6H12O6. What does it mean? It means it will have 6 atoms of carbon, 12 atoms of
Hydrogen,
hydrogen, and again
oxygen.
6 atoms of oxygen. So when all of these atoms, right, 6 of carbon, 12 of hydrogen, and 6 of oxygen comes together, it form a sugar. And this is the chemical formula, or we can say as a molecular formula for sugar. All right. So that is simple, right? It represents the total number of atom. It means how many number of carbon we have? 6. How many number of oxygen we have? 6. How many hydrogen we have? 12, right? That referred as a total formula, right? That's molecular formula, which is kind of simple to understand. The thing that we need to understand is empirical formula. What is empirical formula? Empirical formula is the smallest whole number ratio of each atom of each element present in the molecule. What does it mean? It means if I want to simplify this formula, for example, H2O to the smallest whole number ratio, I cannot do that anymore, right? Because this is 2 of hydrogen, 1 of oxygen. If I want to simplify this, or if I want to write the empirical formula, what do I have to do? I have to divide with the smallest number that we have. In this case is 1. If I divide this by 1, divide this by 1, the number is not going to change anymore. So again, this formula is going to stay same. So in case of water, the molecular formula and the empirical formula is same, because this is the smallest whole number ratio of an atom of each element. However, the empirical formula for sugar is different. Why? because if you look at this formula, the common factor or the smallest number that we are seeing here is 6. So what we can do, we can divide this by 6, each of them. If we do that, the formula look like this. C, 6 cancels out. H, 12 divided by 6 would be 2. And O, 6 cancels out. O, CH2O. What is this? This is called empirical formula for sugar. What did I do? What did I do? I simply found out the smallest whole number ratio of each element, sorry, of each atom of each element. All right, so if you write the formula in this form, this is called empirical formula, right? Do you guys follow this?
Yes.
Yes.
Right? So in example, right? Great. In exam, we can ask you this kind of question. Instead of giving you the name of the like instead of giving you the formula for the compound, I can just say hydrogen peroxide, for example. Right? We don't know the how to write the chemical formula yet, but let's say if you already know this, hydrogen peroxide, I can ask you, write down the empirical formula for hydrogen peroxide. So before you write down the empirical formula, you need to know what is the molecular formula. What is the actual chemical
Formula
formula?
is H2O2 now.
Yes, excellent, right? If you guys, if you know that, it's great. If you don't know yet, of course, we are going to learn about this, right? The hydrogen peroxide, the actual chemical formula, or in this case, we can refer as a molecular formula, is H2O2. It means 2 atoms of hydrogen and 2 atoms of oxygen comes together to make a hydrogen peroxide. This is called molecular formula because this shows all the total number of atoms of each element. However, my question was, what is the empirical formula? For empirical formula, what you can do, you can look at the common factor or the the lowest number. In this case is 2. So you're going to divide both of them by 2. So eventually you are going to end up as H1O1. If there is 1, there is no need to write, right? So HO is referred as empirical formula for hydrogen peroxide. CH2O is referred as empirical formula for sugar. Get it? So it's really simple. Just keep in mind, empirical formula is the smallest whole number ratio, while the molecular formula represent the total number of each atom. Are we good?
Yes.
Yes, sir. Clear.
Yeah, excellent. And what is structure formula? Structure formula, actually, we have to draw the connection between each atom. We can just write down H2O. For example, I'm going to stick to the simple example because we don't know more about this right now. H2O, this is a called molecular formula or chemical formula. If I want to write a structure formula, I had to show that how these atoms are connected. So actually the way they are connected is oxygen is connected to hydrogen on one side, it is connected to hydrogen on the other side, and that's how they form H2O. So what I'm doing here, I'm showing the connection between each atom of an element, right? It shows how these atoms are connected with each other. If I draw a formula like this, then it is called structure formula, which help you understand how they are connected. Okay, so that is called structure formula.
Professor, do you mind doing one more example of the structural formula?
Sure, I can do that.
Like
Right,
maybe
so-
carbon dioxide?
Of course, let's talk about the carbon dioxide then. CO2, right? All right. Anybody who doesn't know right now, it's completely fine. I'm just talking about another compound that's called carbon dioxide. The formula for the carbon dioxide is CO2. Let me just write that formula. The name is carbon dioxide, right? So this is called molecular formula because when one of the carbon attach with 2 of the oxygen atom, it forms CO2, and that's the molecular formula. In this case, let me ask you this. If I want to ask you what is going to be the empirical formula for carbon dioxide, what is going to be your answer?
CO2.
Yeah, CO2.
CO2.
Good job, guys. Great, great. Why? Because there is no way you can simplify this formula any further, right? Or it is already the smallest whole number ratio of an atoms. So yes, in this case for carbon dioxide, molecular formula and the empirical formula is going to stay same. Now let's talk about the structure formula. In the structure formula, what we have to do, we have to show this how this one carbon is connected to two oxygen. So to understand that, of course, we need more theory background for that. But what I'm going to show you is this carbon is going to have double bond, two lines, right? Double bond. Every line is referred as a bond, right? So there are two bond between oxygen, and on the other side, it is again, it's going to have two bond, and there will be one oxygen here. All right. So this, if I represent CO2 in this form, then I can say this is called a structure formula of CO2. Again, you will learn how to draw this formula, how to come up with this kind of structures later on in this course. Okay, so don't worry about that. But this is how we can say if we are showing the connection between each atom, how they are connected, then it is referred as structure formula. Are we good? Any question?
Yes, sir.
Excellent. Right now, as I just told you, what we are going to talk about is there are two different type of compounds. So far we talk about, all the basics, right? What is atom, what is element, what is compound, what is molecule, what are the isotopes. Now we are going to talk about what are the different type of compound that we are going to learn. There are basically two different type of compound we are going to learn. The first one is called a molecular compound, or it can also refer as covalent compound. All right, we can call it as a molecular compound, or we can call it as a covalent compound. And the second type is called an ionic compound. So first of all, you need to identify what is the difference between these two, right? So this difference, I would definitely suggest you to remember this. This is kind of easy difference. It's not like that hard, easy to remember. But as long as you pay attention to this, it will be very, very helpful. Because let's say, for example, if in an exam, if I'm going to ask you, I can ask you like different type of question. I can give you the formula and I can ask you, do you think this is ionic compound or it is a molecular compound? How can you figure that out? Only by knowing this difference, right? The table that you have in front of you. If you understand that, you will be able to answer those kind of question. So what molecular compound is composed of, right? So element, right? These are the different, I can say the different topics that we're going to talk about for this molecular compound as well as ionic compound. For the molecular compound, how do we know what molecular compound is composed of? Remember, molecular compound is always composed of two or more non-metal elements. All right. If you remember, what are the non-metal? The non-metal are the one which is generally are on the right side of the periodic table, or we can say right side of the metalloids. So if you see two elements coming together, or even more elements coming together, two or more, and all of them are from the non-metal section of the periodic table, then you can say this is a molecular compound, or you can say this is covalent compound. Let me ask you for this, right? If I give you this example, CO2, look at the periodic table, find out where is carbon, find out where is oxygen, and can you guys let me know, is it a molecular compound or not? I'm not talking about ionic right now. Is it a molecular or not?
No,
No.
It's molecular.
We're talking about carbon dioxide.
Yes. So you have to look at the periodic table and you have to find where is carbon, C, and where is oxygen, O.
I think it's a molecular.
Yeah, I think so too.
I would agree
Molecular.
with that.
It's
Right.
molecular.
It is molecular. That's great. That's great. And everybody who doesn't know, I would definitely suggest you to highlight the metalloid across your periodic table. So in case if you want to print that periodic table out, highlight the metalloids, right? Make the like blue mark or red mark so you can easily see them. As long as you can see them, you will be able to identify the carbon is on the right side of the metalloid. Oxygen is also on the right side. It means both of them, two elements that we have in this chemical formula, are non-metals. If they are non-metals, then we can call it, yes, this compound is a molecular compound or covalent compound. Okay. What is the ionic compound then? The ionic compound will always have one metal and one non-metal, right? So basically I can say when there is a combination of metal and non-metal, then it is called a ionic compound. In a simple word, we can say as long as you see one metal element in the chemical formula, you can say this is ionic compound. All right, again, if you see one metal element, then it is an ionic compound, because ionic compound is a combination of metal and non-metal, while the molecular compound is a combination of two or more non-metals. Okay. Example, NaCl. NaCl is a chemical formula of a table salt, or generally the salt that we eat in our routine life, right? NaCl is a salt. If I'm going to ask you, Na is one element, Cl is another element, I'm going to ask you to refer to the periodic table, find out where is Na, find out where is Cl, and let me know, do you think this is a molecular compound or ionic compound?
Ionic compound,
Ionic compound.
because
I'm gonna
sodium
give you
is ionic compound because sodium is metal and
excellent.
chloride is non-metal.
Excellent, right? Chlorine is non-metal, sodium is a metal, right? So that's why I say, as long as you kind of be familiar with first 36 element, right? This can save your time. As long as you are familiar with it, as long as you know where they are located, right? Of course, you need more practice, but make sure you spend enough time looking at the periodic table, try to kind of at least memorize somewhat that which side of the periodic table you may have to look for, Na or Mg or K or Ca, which side of the table you have to look for, like oxygen, fluorine, nitrogen, right? For those. So just, keep practicing, you will get this. In this case, yes, Na is a metal. It is located on the left side of the periodic table. Cl is a non-metal. It is located on the right side of the periodic table. And that's why we can call this as an ionic compound. All right, so that is the first thing everybody must remember, that this is the something you need to know in order to identify whether it's ionic or molecular compound. Now, everything we are going to talk about, it is generally knowing about how we can explain this in more detail. This is not something you need them to identify this. Okay, the type of the bond, which type of bond these compounds will have, very simple. Covalent compound or molecular compound, right? Why do we call it as a covalent compound? Because the type of the bond they are having is called covalent bond. And that is the reason why we call molecular compound as a covalent compound as well. Okay, so the type of the bond we have in the molecular compound is covalent bond, while in the ionic compound, the type of bond is called ionic, right? That's how we came up with this name. Ionic compound will have ionic bond, covalent compound will have covalent bond. How do they form, right? Of course, you need to know a little bit more detail about this, which we are not going to kind of touch the basis right now, but you will understand this in detail in your lecture, that how they are forming, how do they make the covalent bond. So the covalent bond formed by sharing electrons. So let's say if I have one electron, let's say if you have one electron, what do we do? I help you, you help me, and that's how it stay connected, right? What is the connection here for us, right? For me, let's say if I don't know how to swim, and if you don't know chemistry, if I teach you chemistry, if you teach me swimming, right, that kind of connection is considered as a sharing, right? You are teaching me one thing, I'm teaching you one thing, we are helping out each other, right? That is kind of what happened here, right? Sharing electrons. That's how they form the connection. That's how they form the compound. In terms of ionic compound, what they do, they transfer the electron. So there's a difference, right? Sharing means you give me one, I give you one. Transfer means I give you one and you give me something else, or you don't give me something, anything, right? That's called transfer. It means in here, we can define this as a donating and accepting, accept, right? If you want to describe what is transfer mean, so one element is going to donate electron, the second element is going to accept electron. So in this case, right, in this generalized idea, what I'm doing right now is I am sharing my knowledge with you. So I am donating my knowledge and you are accepting that knowledge, right? So that kind of connection, which is kind of one way in that case, right? That can be referred as a ionic compound. Okay. Do you guys follow this?
Yes.
Yes.
Right? Excellent. Something to remember as a multiple choice question in the exam. I personally like to ask this kind of question, that if it's a true or false. The question says, when you mix different compound in the water, are they going to stay as the compound itself? Are they going to break down? Right? So if I'm going to ask you what happens if we are mixing it with the water, for the molecular compound or covalent compound, when you mix or dissolve in a water, they are staying intact. They are going to stay as a molecule itself. The example is C6H12O6. This is the sugar, right? I think everybody must have seen it. If you take a cup of water, if you take 1 teaspoon of sugar, if you dissolve that in a water, or if you mix it, it will dissolve. However, it will not fragment out. It will not break down. It stays as it is. Why? Because it is a molecular compound. Okay, it's gonna stay as it is. While in the other case, if you take the same cup of water, if you add salt instead of sugar, right, NaCl, salt. If you add salt into this, again, it will dissolve when you mix it well. However, it is not going to stay as an NaCl anymore. Why? Because it is an ionic compound. Ionic compound is composed of metal and non-metal. And in this case, what we just talked about, what they do, they transfer the electron. It means they are going to produce ions. So ionic compound, let me just write this here. Do I have that here? Yeah, I already have that detail here. Ionic compound, what kind of element they are composed of? We can say, yes, it is composed of metal and the non-metal. But if you want to refer this as how we can make the ionic compound, we can make the ionic compound by having a positive charge ion and negative charge ion, right? It says ion. Ion means something that is carrying a charge. There are two different types of charge that they can carry: positive charge and the negative charge. Okay, so generally the ionic compound is composed of metal element, which is always carrying plus charge. And it is also composed of non-metal element, which is always carrying negative charge. So because of the positive charge and the negative charge attraction, they are holding together. That's why we call it as an ionic bond. There is a strong attraction between ion, positive ion and the negative ion. Okay, which one is going to form a positive ion? The metal element is going to form a positive ion. Non-metal element is going to form a negative ion. So when you mix this in a water, what is going to happen? They're gonna dissociate or break down. So what is going to happen if you dissolve NaCl in the water? It will form Na plus ion and it will form Cl minus ion. So now it has been broken down. Broken down into what? Into ions. Okay, so that is the difference. Ionic compound does break down in a water and form ions, while molecular compound can dissolve in a water. However, they do not dissociate or do not break down. Okay, and it is the same connection for the conductivity. Because the ionic compound dissociate into ions, they can conduct the electricity or heat. That is the reason why we can conduct the electricity or heat if there is an ionic solution. However, it cannot conduct the electricity and heat if it's a molecular compound. Okay, if it's a molecular compound, it will not conduct the electricity and heat. All right, do you get it?
Yes,
Yep.
sir.
Yeah.
Yes.
Do you have any question?
No,
No, sir.
No? Okay. This is again just to remember, right? Of course, we are going to talk about this in a detail, right? But when I say positive ion, right? Which element is going to form a positive ion? Always metal element is going to form a positive ion. Which element is going to form a negative ion? Always non-metal, Nm, is going to form a negative ion. Instead of calling it as a positive ion and negative ion in this course, or basically in the chemistry, what do we call that? Positive ion, we call them as a cation. Cation. All right, so you should be familiar with this term. Whenever we talk about the cation, it means the ion that are carrying plus charge or positive charge. What are the negative charge ion called? The negative ion charge like call anion. All right, so instead of calling it a negative ion, we can call it as a anion. I just told you that metal will form a cation, non-metal will form an anion. Okay, and what is the positive charge, or how we can get the positive charge? So this is something, it's not so tricky, but it could be a little tricky for somebody to understand. So what we call is, let me just write this down here. Should I explain this? Okay, let me just take the simple example. Hydrogen, right? If I'm going to ask you right now, what is the atomic number of hydrogen?
1.
Okay, I think hydrogen would be too simple. Sorry, hydrogen, helium, lithium. Okay, let's talk about lithium so it will be easy to understand. Lithium, right? Let's talk about lithium. What is the atomic number for lithium?
3.
Great, right? Atomic number for lithium is 3. It means the number of proton would be
3.
great.
Great job, guys, right? So 3 proton, and number of electron would be
3.
great, right? Very, very great. Excellent. So in here, what we talk about, if lithium is going to form an ion, what kind of ion is going to form? Positive ion or negative ion?
Positive.
Positive. Why? Because lithium is a metal, right? It will form a positive ion. Okay. The same way we can talk about another element, which is, let's say for fluorine, right? We can talk about fluorine, atomic number is 9, number of proton would be 9, and number of electron would be 9. Okay. If I'm going to ask you what type of ion fluorine is going to form, we can say it is going to be
Negative.
negative. Excellent, right? The reason is because it is non-metal, and non-metal will always form a negative ion. Okay, so what you mean by positive ion and negative ion? So if you want to form a positive ion, let's focus on the lithium, right? To be able to convert from lithium to lithium plus, what is happening? It means it is gaining +1 charge, right? +1 means it is gaining +1 charge. However, what we just talk about, we talk about that if you want to form an ionic compound, The only thing happens is transfer of electron. So it is only about exchanging electron, not about exchanging the proton. Okay, electron carries negative charge, and we are exchanging the electron to form a cation, which is a positive ion, and also form a negative ion, anion. So if lithium lose one electron, right? I say E minus because electron generally carry negative charge, so I can help you understand this. If lithium lose one electron, then it can become as a lithium ion, which is lithium plus, Li plus. Right? In here, we are not talking about gaining or getting one more proton because there is no exchange of the proton. The only thing, the only particle which get exchanged is electron. If lithium loses one electron, it means it's becoming less negative. If you say if it's less negative, you can also refer that as a little bit of positive. And that's how we have to look at it. Do you follow this? Lithium, if you want to form a lithium plus ion, it is going to lose one electron. It means it's going to donate one electron, in the other word.
Can you repeat again, Professor? I'm sorry.
Yeah, no problem, of course. Right? I'm going to repeat that. Let me just explain you the other side of this, right? And then I'm going to repeat it, okay? For
Thank you.
fluorine, yep. For fluorine, if fluorine is having 9 proton, 9 electron, and if you want to convert that into F minus, this is easy to understand, I think. So how can you convert F into F minus? If it accept one electron, right? Gaining of, what happened? Accept one electron. Do you guys agree? If fluorine is going to gain one electron, then it will become F minus. It will have one negative charge because electron is carrying negative charge. Yeah.
Mm-hmm. Yeah.
Right. So for an element to become a negative charge, right? For example, Cl to become Cl minus, what it has to do? It has, right? What it has to do? It has to gain one electron. Yeah. That's how you can make Cl into Cl minus. However, the trick, this is kind of little bit hard to visualize this, right? For Na, for example, Na to become Na plus. Can you guys see the screen properly, or
No.
it's just no, right? Yeah.
Nope. You just disappeared.
Yeah. Screen showing. Okay. All right. Okay. Okay. Choose share. Okay. I'm gonna just gonna use the whiteboard now. Right. So for fluorine, what we just say, fluorine to become F minus, Cl to become Cl minus, what actually happened in this case, it gain one electron, right? If you gain one electron, it become a F minus or Cl minus. However, for the cation, or what is going to happen, Na to become Na plus, another case would be potassium, K to become K plus. What is going to happen? In here, we cannot just say gain proton because there is no exchange of the proton. So what we're going to say, this is loss of electron, or say donate one electron. Do you understand it now?
Yeah.
Right. So remember, this is something, it's not kind of straightforward to understand, but as long as you focus on this part, sorry, the negative ion or anion pod, you will be able to understand how you form a cation or positive ion. So element to anion, which is negative charge, and element to cation, which is a positive charge. And here what happened, it is gaining of electron, and in this case donating electron. All right, so if you want to convert element into ion, anion, you have to, it will gain 1 electron or maybe 2 electrons, right? For element to convert into cation or positive ion, it will be donating electron. All right, do you guys follow this?
Yes, sir.
Everyone?
Everyone? A
Yes.
question, sir. Can
Yes.
you repeat the correlation between the positive and negative ions and the metals and non-metals, please?
Sure. So I'm gonna clear this, clear or right. So you can say molecular compound or covalent compound, and the second type is ionic compound. Okay, this is always composed of non-metal and non-metal. Nm means non-metal, right? So molecular compound or covalent compound will always have 2 or more non-metal, while for the ionic compound you are always going to see metal connected with non-metal. Okay, in this case it is composed of ions. For ionic compound, it is composed of ion. What type of ion? Positive ion, negative ion. What we call positive ion as? We call it as a cation. What do we call as a negative ion? We call it as an anion. So when you dissolve NaCl or any ionic compound in a water, what is going to happen? They are going to dissociate or break down into this ionic form, right? And if you have ions, because it is carrying charge, right, you can pass the heat or you can pass the electricity. What I'm going to do, I'm going to share a nice experiment with you to help you understand molecular compound and ionic compound. It's really cool. Okay, I'm going to share that with you before we finish. Okay, so that's how it can pass the electricity. So can conduct electricity. So I'm not sure if you have seen all the cables that you use for your charger, right? If you ever open this kind of cable, you will see there is a metal in it. Why there is a metal, right? Why it is composed of, like, you know, like a copper metal or something like that? The reason is they are the metal which actually can pass the electricity. Okay, that is the reason. For molecular compound, it is always non-metal, right? How do we form? They just share electrons. Sharing of electrons. So if there is sharing, it means there is no ion, right? They do not form any ion. The ion only form when they donate, right? In here, I would say donate / accept electron. So if one element is going to donate, the second element is going to accept the electron. And that's how they form the charges, or that's how they form the ions. In this case, they share the electrons, so none of them is going to form any sort of ions. If they do not have any ions, right, it will not conduct the electricity. Also, when you dissolve that in a water, they do not break down into ions because they do not form ions, right? So they stay as it is. So they stay when dissolve in water, I should say mix. When mix with water, they stay as a molecule. Yeah. Do you follow this?
Yes.
Yes.
Yes, sir.
Yeah. All right. Any question? Please mute. All right. Can you please mute yourself? All right. Great. Thanks. All right. So let me just share how many different type of, where is it? Okay. I think I have closed that window. Let me just open that. Okay. So I'm going to share this. Form. All right. What did I just say? Right. We talk about different ions. Oops. Sorry, guys. Let me. All right. Something happened to my. I can share this now. Share. All right. So if you guys remember this, I did share this picture with you, right? The handout with you. In here, what are we talking about? We are talking about different element that can form different charges. Everybody can see the table, right?
Yes,
Yes.
sir.
Yeah, awesome. So this is the kind of same periodic table that I share with you. Instead of representing all the element here, what did I do? I just highlighted the I would say the ions and what charges they can carry. All right. So I would just give you the general idea. The blue background that you're seeing after each, like on each boxes, that are referred as a metal element. The green background that you see, which is like in a zigzag fashion, that are metalloids, and the yellow background elements are non-metals. Now, if you remember, I did talk about the different group number and what is the use of the group number that we're gonna learn right now, right? So if you remember, I said there are two ways to label the group. The first one is just write down the numerical value 1, 2, 3, 4, 5, 6, 7, and up to 18, right? Let's just keep on. Oops. All right. Okay. Right. I cannot write on the screen, so I'm just gonna say there is a numerical value that you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 12 up to 18. That's the one way to label the group. The other way to label the group is writing a number and the alphabetical or A, right? So it's a 1A, then it's 2A. The middle section, the middle small section of the periodic table, we're going to skip it. Then we're going to go on the right side of the table and we're going to call it as a 3A, 4A, 5A, 6A, 7A, and 8A. Can everybody see that? The one?
Yes.
Yes.
So what that group number says, that group number tells you that all the element present in that group can carry what charges. Okay, so every element which you have in a group number 1A, if you look at them, all of them will be carrying plus 1 charge. Every element in group number 2A, they are carrying plus 2 charge, right? If you look at the group number 3A, aluminum Al, that is carrying plus 3 charge. So what we just learned, we learned that group number 1A, group number 2A, and group number 3A If you have element in them, we can say it is carrying +1 charge if it's group number 1A, carrying +2 charge if it's in group number 2A, and carrying +3 charge if it's in group number 3A, right? In 3A, we are only going to refer to aluminum for this course, right? So you can stick to the aluminum only. All right. Now, if you look at the group number from the right side, right? If you look at the group number 8A, they do not have any charge. The reason is, if you remember, the name of that group is called noble gases. Noble gases are the element which do not like to react with anything. They are happy by themselves. They do not like to share electron. They do not like to gain electron. They do not like to donate electron, right? So they are happy. So they are not going to be involved in forming ionic compound. However, if you look at group number 7A, right? From this group number 7A, we can say they are going to form -1, right? They are always going to be -1 charge. Group number 6A always going to be -2 charge, and group number 5A always going to be -3 charge. All right. So from left to the right, we can say group number 1A, 2A, and 3A, +1, +2, +3. On the right side, we're going to skip the first column, or we can say first group, which is noble gas. Moving on to the second to the last, which is going to be halogen, or 7A, we can say -1, then 6A will be -2, and 5A is going to be -3. All right, these are the common charges we are going to see. So if we talk about fluorine, which is F, it is always going to be -1 charge. If you talk about oxygen as an ion, it will always going to be -2 charge, and so on. Do you guys follow this? Yeah. So it's easy.
Yes.
Yeah. So keep this table handy with you, right, during your semester, and it's gonna make your life really easy. Okay. I'm not going to talk about the middle section of this table in the detail. However, I will definitely mention that if you remember, I told you that the middle section has a particular name which is called transition element. And the reason why we call it as a transition element is that this element can have more than one charges, just like the one that you're seeing here, Cr, chromium. It can exist as a +2, or it could be +3. The next one is manganese, Mn. Again, it could be +2 or it could be +3, right? That is the reason why we call it as a transition element, because they are carrying more than one charges. However, all the elements that we just talked about, group number 1A, 2A, 3A, 5A, 6A, and 7A, they are always the same charge. They will never carry, like fluorine, for example, from group number 7A. It will never be F-2 or F-3 or F+1, F+2, never. It is always going to be F-. Okay, so that's true for group number 1A, 2A, 3A, 5A, 6A, and 7A. However, if you talk about transition element, it is not true. It means it can carry more than one charge. In the transition element, there are only 3 charges or 3 ions that you need to remember, I would say, or at least keep them handy, or try to kind of highlight them, which only carries one charge. The element is zinc +2, Zn +2, from group number 12, right? Zinc +2, it is one of the 3 elements which always carry +2 charge, right? Cd, cadmium, is the another one which belongs to the transition element. However, it will always form +2. And the one before that, Ag+, silver, that is also another transition element which always form +1 charge. So these are the 3 exceptions across the period, across the transition element. Otherwise, most of the transition element carries more than one charge. It means it could be +1, or it will be 2, or it could be +3, right? In some cases, as you can see, Pb on the right bottom corner, Pb, it can be +2 as well, it can be +4. Bi, it could be +3 or B5 or +5. Yeah, so just keep this table handy, review them whenever you have time. All right, you can remember this for sure, right? If you can, it's okay, you can also have this table handy with you. Okay, try to focus on the element which always carry the same charge. Try to focus on the element which can have two different charge, right? And it's not that hard. All right, so keep this table handy with you. Do you guys have any question from this? Probably we can discuss the name today, but I would definitely suggest you to review this table, keep this table handy with you for the tomorrow's session. Okay, we are going to use these names and the charge in order to write the chemical formula and the names. Okay, anybody has any question?
No, sir.
No. Okay, so what I'm going to do, I'm just going to stop sharing this, and as I promise you, I'm just gonna look for one video that can help you understand the difference between the molecular compound and the covalent compound. So just give me 1 minute. I'm gonna look for the video. I'm gonna share that with you. Okay. All right. So I'm gonna mute myself. Okay, guys. So, in the chat box, I just share a link with you, right? Please watch this video. It will help you to understand how the electricity can conduct in the ionic solution and how it cannot in the molecular compound or molecular solution. Okay, it will definitely, it is really one of the fascinating experiment, right? If you, I think it will definitely help you understand it even more. If you have